Okay, when you go to analyze a big 16 square Punnett score like this, it would be really mean of me to ask you to do a genotype ratio because there's so many different possible genotypes between two parents. So I probably wouldn't ask you to do that. You'd have to write down all the possible combinations and count them all up. But I am going to have you probably do a phenotype ratio, which means you need to go through and count up how many of the 16 squares of the offspring would turn out dominant in both traits, how many of these would turn out dominant in one trait, recessive in the other, how many will be recessive in the opposite trait and dominant in the opposite trait, and how many will be recessive in both traits. So let's count them. To do that, I usually mark them so I can make sure I'm counting all 16 and then add them up and make sure they add up to 16. The number that are gray and brown have to have at least one big G and one big B, so I'm going to put an X through those. I'm going to go 1, 2, oh, these didn't get filled in. 3, 4, 5, 6. 6 out of 16 possibilities would have dominant both traits. These guys are going to have a dominant G in them, but no big B's at all. So let's put a little dot in those. 1, 2. These guys don't have any big G's, so just 2 out of 16. These babies would have a big B in them, but only little G's. Let's put a circle around those guys. This one is 1, 2, 3, 4, 5, 6. And the ones that are going to be recessive in both, I'm going to shade them out completely. That would be this one and this one. So I have a 6 and 16. 6/16 is the same thing as 3/8 chance of having a gray-eyed child with brown hair. Only a 1/8 chance of having a gray-eyed child with blonde hair. A 3/8 chance of having a blue-eyed child with brown hair, and a 1/8 chance of having a blue-eyed child with blonde hair. So let's look at my kids and see what they ended up turning out like.